For thousands of years, fabric was the ultimate temporary shelter, the nomadic tent, the circus big top. It was practical, portable, but never permanent. But what if I told you that fabric is no longer just for temporary cover? It has evolved into a sophisticated, high-performance building material capable of creating some of the most breathtaking and iconic structures on the planet. We're talking about stadiums that look like glass mountains, airports with peaked roofs that seem to float, and pavilions that mimic the natural forms of leaves and spiderwebs. This is tensile fabric architecture, and it represents a fundamental shift from the tradition of compression and mass to the elegance of tension and surface. In this video, we're going to pull back the curtain on how cloth and foil are engineered to become building skins, how they defy gravity, and why they might be one of the most sustainable choices for the future. Let's start with the materials themselves, because we're not talking about cotton or canvas. Modern architectural fabrics are highly engineered composites. The most common types form a layered system. First, there's the base cloth, a grid of fibers that provides the tensile strength. The two most common are fiberglass and polyester. Fiberglass is incredibly strong and resistant to creep, which is the permanent stretching under long-term load. This makes it ideal for permanent structures. Polyester is more flexible and elastic, often used for structures that may need to be tensioned and retensioned. But the raw fibers aren't enough. They are coated and laminated to become weatherproof and durable. The most iconic coating is PTFE, better known by the brand name Teflon. A PTFE-coated fiberglass membrane starts off a little brownish, but when tensioned and exposed to sunlight, it undergoes a process called sintering, becoming brilliantly white. It's incredibly durable, fire-resistant, and self-cleaning. Rain literally washes the dirt off. It's the material used on the roof of the Denver International Airport. The other workhorse is PVC-coated polyester. This is a more flexible and cost-effective option, often used for mid-term and large-scale structures. To protect the PVC from UV degradation and dirt, it's usually finished with a top layer of PVDF, like a clear coat on a car. Then there's the high-tech star, ETFE. This isn't a woven fabric. It's a transparent fluoropolymer foil, often used in inflated cushions. It's only about 1% the weight of glass, has incredible light transmission, and is extremely durable. The most famous example is the water cube from the Beijing Olympics. A pro tip for material selection. PTFE fiberglass is for permanent, iconic statements. PVC polyester offers great value and flexibility, and ETFE is your go-to for transparent, lightweight enclosures. Now, what does it take to actually build one of these structures? The process is a carefully choreographed sequence that is the opposite of conventional construction. It begins with a primary structure, typically a ring beam, arches, or a series of masts and cables. This steel skeleton defines the overall geometry and provides the anchor points for the fabric. Next comes the installation of the fabric. This is a high-stakes operation. The prefabricated fabric panels, which can be the size of multiple tennis courts, are carefully unfolded on the ground. Then, using a combination of cranes, winches, and a lot of careful hands, the fabric is lifted and connected to the primary structure at key points. The final and most critical phase is tensioning. This isn't a single step. It's a gradual, systematic process of tightening the perimeter cables and edge details. The crew works their way around the structure, applying tension in small increments, watching as the wrinkles slowly disappear and the fabric transforms from a loose sheet into a taut, rigid, and stable surface. A common and costly mistake is to tension one area too much too quickly, which can rip the fabric or overstress the connections. The advantages of fabric structures are profound. First, they are incredibly lightweight, drastically reducing the amount of material needed in the primary support structure and the foundations. This leads to faster construction and lower embodied energy. Second, they offer massive clear span capabilities, creating vast, column-free spaces ideal for stadiums, airports, and convention centers. Third, their aesthetic and formal possibilities are virtually limitless, allowing for organic, fluid shapes that are impossible with rigid materials. And fourth, they have significant sustainability benefits. The white or translucent membranes have high solar reflectance, reducing the urban heat island effect. The translucency also allows for abundant, glare-free, natural daylight, slashing the need for artificial lighting during the day. Of course, there are challenges and considerations. The initial cost can be high, and the design process requires specialized engineering expertise. While modern fabrics like PTFE can have a lifespan of 30 plus years, they are not as permanent as concrete or steel in a centuries-long sense. Thermal and acoustic performance, while good, often requires additional layers or integrated systems to match the performance of an insulated wall. However, when you look at the iconic profiles of the Munich Olympic Stadium, the Millennium Dome in London, or the Hajj Terminal in Saudi Arabia, you see a material that has truly come of age. It's no longer just fabric, it's architecture. In conclusion, fabric as a building material challenges our very definition of what a building should be. It moves us from heavy, static, opaque boxes to light, dynamic, and luminous environments. It represents a beautiful synergy between ancient craft and cutting-edge technology, between artistic expression and rigorous engineering. For architects and engineers, mastering tensile fabric means adding a powerful tool to your palette, one that allows you to create shelter that is not just built, but is precisely and elegantly tuned. Now I want to hear from you. What is the most impressive or inspiring fabric structure you've ever seen or experienced in person? Let me know in the comments below. If this look into the future of fabric has expanded your idea of what's possible, please give this video a like and subscribe for more content exploring the frontiers of architecture and engineering.